Hi, everyone. My name is Tessy, and I am a learning manager at the Raspberry Pi Foundation.
And hi, I'm Veronica. I'm a research scientist here at the Raspberry Pi Foundation. In this webinar, we're talking about bias and ethics. And it's actually the last webinar of the series, which is quite sad, but it's also the webinar I'm most excited about. Bias, fair representation, and ethical machine learning model design are such important issues, and ones that cut through all of the AI-related topics we've been talking about so far in all the previous webinars. What do you think, Tessy?
Yeah, absolutely. Like there's so much focus right now on the amazing possibilities that AI can bring and the future opportunities they present. But we've already started witnessing examples of bias, both in the data set and in the application of AI. So I'm really excited to be a part of this conversation and insights our special guests will share today.
Definitely. But before we go any further, if you have any questions during the webinar, please ask your questions in the chat and we'll do our best to answer them at the end of this webinar.
Absolutely. Make sure you do. So without further ado, we have a very exciting guest joining us today. You might recognize Antonia from the videos in lesson 6, where she talks about model cards. Welcome, Antonia.
Oh, thank you so much for having me. I'm very excited to be here.
Hi, Antonia. Very nice to see you. Can you tell us a little bit about what you do at Google DeepMind and how you got there?
Yeah, absolutely. So first of all, I just want to say it's really great to be here and hear about all the amazing work that Raspberry Pi is doing in education around AI. It's a really important topic. So just a bit of background about me. I have been working at Google DeepMind for almost 5 years. And before joining, I experimented with a few different roles. So I had a role at the Science Museum. I worked in a science technology startup. And I also ran a small charity for a bit of time as well. But what do I do at Google DeepMind? So our mission at Google DeepMind is to build AI responsibly to benefit humanity. And in order to do so, this requires a strong culture of responsibility across the organization. But it's the role of my team in particular to ensure that all of our work upholds these values. So my team is called READY, which stands for Responsible Development and Innovation, bit of a mouthful. And we kind of partner with teams across Google to identify the benefits and risks of different research areas, understand and monitor the impacts of our work, and support in finding kind of appropriate mitigations. We also support Google DeepMind's ethical governance forum called the Responsibility and Safety Council, which is tasked with reviewing projects in line with our principles. It's kind of like an ethical charter, if you will.
Wow, it's so good to hear so much about what you do. Oh, I think we're losing the network just a little bit.
Oh, you there?
I can hear you fine.
Can hear you fine? Yes, carry on, Antonia.
Perfect. Well, I mean, that was kind of like an introduction as to what I do at DeepMind. Do you have any other kind of questions that you want to ask about that?
Brilliant, Antonia. So we're going to intro the series because we have a few resources across the 6 series that we do. We're just going to put the slides on live. Fantastic. So this webinar, as Veronica has said, which is our last webinar, which is quite sad, fits in as part of our Experience AI 6-lesson series, which was developed by the team at the foundation. So in this lesson, we cover bias and ethics, and we cover bias and ethics throughout the unit. But the first time you will be introduced to it formally to your students is in this lesson, lesson 3. And we're going to show you some of the activities from this lesson today. In lessons 5 and 6, your students will create their very own machine learning models to solve a real world problem. And it's important that they're thinking about the ethical issues associated with their models and any bias that might be present. And this is the same for all technology related topics as well. So it's very key here. And then again, these are covered again in lesson 6. So Veronica, let's delve right in using a common real life example, because that's good to show relevance to students that apply to their lives. There's a really good introduction to bias from this lesson resource.
Thanks, Tessy. Yes, for sure. Let's get started. And in order to get to the definition of bias, we'll use, like Tessy said, a real example of a supermarket, looking to use an AI system to recognize the items shoppers place or take out of their baskets, to reduce or even remove checkout time altogether. You might have direct experience of this. I went into the Amazon Fresh supermarket in London a couple of times, where you just enter by checking in with your smartphone, with a smartphone app. And you're just automatically billed when you exit. So you don't scan any individual items, you don't check out at all, and you just literally really walk out. Have you ever been there, Tessy?
No, I haven't, but I can just imagine. Can you like trick it and take things out and put it back in and take things out? Can you do that? Did you try that?
I didn't. I should have, but I do know one of my colleagues did, and it was very accurate. So
Oh, okay. All right. No, I haven't tried it, but I bet it's better than struggling at the self-service checkouts like I do.
for sure. So such a system would require the use of cameras to recognize these items that customers put or remove from their baskets. In the lesson, your students get to partly design the system. So first, we need to build a model, a machine learning model. And as a quick reminder, a model is a representation of a real world context. And students will actually get to partly build this model using the Machine Learning for Kids platform, the details of which are all in the lesson. And they will train it to recognize apples and tomatoes. What kind of data would you recommend to build such a system, Antonia?
Well, it's really important for the data to be representative of what the model is likely to see in the real world. So this would kind of be images of different types of tomatoes and different types of apples for this.
Yeah, pretty much. And once we've got such a data set representative of the real world context, in this case, the apples and the tomatoes we see in supermarkets, we use some of it to train the model, and we keep some of it to test it. And critically, these do need to be different. These data sets do need to be different. So this is actually an example of the type of images that your students are provided with in the lesson to train their model. What do you think, Tessy? Do you think they've got enough data there to train their models?
Oh, looking at these images straight away, I mean, on this example, we can identify that they haven't. And it's important to think about the number of examples needed to train a model. So I didn't realize that machine learning models require thousands of examples to be trained effectively so that they can be accurate. So just imagine that effort, for people to find these images and label them. I mean, luckily in this lesson resource, the machine learning for kids, that software doesn't need lots and lots, thousands. So you can actually use a minimum of 6, which is more suitable for the classroom. And it's unlikely, though, that the model will be accurate enough. So when students are doing this exercise, I've seen a few of them, they realize their model isn't accurate enough. In fact, when I did this exercise, I realized the model wasn't accurate enough. And then you go back and you train it again until you see if it improves that accuracy. It's also worth noting that not all the images that the students are provided with are representative of the kind of apples you would find in a supermarket, because you've got so many different types of apples and cooking apples and all of that. And some of the images are cartoon images of apples, and you might have spotted that in the training data. There's no images of any red apples as well. And those are my favorite apples, so definitely it won't recognize what my favorite apples are. There's only green apples there. And it's a real reminder that although we can rely on technology to improve lives, we've got to ensure that there's accurate data to create and train these type of technologies, so lots of error and bias don't occur.
Definitely. And part of the value in this hands-on activity for students is to experiment with different types of data, different volumes of data, and see some of these limitations coming to the fore. And I wonder, Antonia, do you see some of these real life, these limitations in real life models as well?
Yeah, absolutely. We see these types of limitations across all types of models, and not just these kind of like image recognition models, for example. I can give a bit more about the types of bias that we've seen in different types of models, if that's helpful.
Yeah, can you give us one example where maybe the data, just like here, for example, where the size and shape of tomatoes and apples aren't really representative of what we see in supermarkets. Do you have one example that maybe relates to this?
Yeah, so it's important to remember that kind of bias is a very, very big topic in analytics. And it is because there have been countless historic examples of algorithms perpetuating kind of unfair outcomes in society. And this is super important when systems are being used to kind of aid decision making, like they are in this example. So we might see how data might be trained, like a model might be trained to recognize faces for facial recognition, like the type of algorithm that's used to kind of unlock your phone, for example. But if that data has not been trained on a range of imagery that is representative of society, then it will perform differently across different groups.
That's such a powerful example. Yes, I think tomatoes and apples are less kind of life changing or impact people's lives, but certainly facial recognition systems have the potential to really influence the way in which people go about their daily lives.
Wow. So from everything we've discussed so far, we can safely conclude on a definition of bias, of AI bias. And this is when a machine learning model favors some things or groups and excludes others. And Antonia, just picking up from what you said earlier, we've already seen so many examples, like in an article I read with that facial recognition example, it was stating that the software that was used could recognize white males, middle-aged white males, 90% of the time, but like Black females, only 70% or less of the time, right? And then another example is if a social media platform starts showing like tech-related jobs, programming jobs, to only those who identify as male. So these examples of bias, they cause real concern under like underrepresented communities, already marginalized groups who start thinking, well, I'm already disadvantaged in society. I don't want to adopt any technology that would already worsen, how I'm already faring in society, put me behind. So, but thinking about bias again, then we can put it into two sections: data bias and societal bias. And those two are different based on the facial recognition software versus the apples and the tomatoes example that we saw earlier. So data bias refers to the data sets used to actually train machine learning models, such as those in the supermarket and the facial recognition examples. And when the data used does not accurately represent what is being modeled, then this can cause bias. So hence why it needs thousands and thousands of images to train, an AI machine learning model. And on the other hand, then we have societal bias, where that the data that is being used to train the model reflects the bias that's in society. So, what do we traditionally see women do, or what do we traditionally see Black people or white people do? And because this bias exists in society, just imagine if there was like a career prediction model and it was asked to, predict our jobs. In fact, the three of us in this webinar now, imagine the kind of outdated bias that would be involved in such a model. And because majority of the AI developed is done by large tech companies in the Western world, there are some really ethical debates that we need to consider. So for example, who gets to decide what equality is, right? So we're doing all of these, we're inventing so much technology because we want equality and equity. But we're always pushing for that from a Western perspective, or from, a certain angle of our lived experiences. And if one company determines the values and creates all the models, does that become the norm for the rest of the world? If multiple companies, so if I say, I don't want to say any brand names, so if I say TikTok, for example, decides what all of us see, and they always determine what we see in our entertainment, on our reels, all of that. So if those specific companies are developing AI technologies and they're based in only one part of the world, would they understand the cultural context needed to define equality for the rest of the world in a way that's fair for everyone. So I wonder what generative AI would say, like a few of the, again, I can't mention brands, but if I say like ChatGPT and not get quoted for it, what would ChatGPT say if we typed it in and said, what is equality? So Antonia, what examples of bias have you seen and are you aware of in relation to bias, apart from the facial recognition example that you already gave?
Yeah, absolutely. So, I mean, you've already mentioned how this, bias can lead to unfair job opportunities based on race or gender. We've also seen examples in things like the criminal justice system, including a very famous case where predictions of whether or not criminals were likely to reoffend were found to be incredibly racially biased. I think more generally, it's really important, you've alluded to this already, to understand that technology is not value neutral, and that without really examining the type of data that goes into training models or evaluating the outcomes of those models, it can exacerbate the social injustices that already exist in our society. So you mentioned as well that the values that we might want to align our technologies to are likely to change across different countries and different cultures. This is certainly true, and why it's so important that companies like us kind of engage with as many stakeholders as possible to really understand how that technology might impact different groups and what they really want to get out of using technology.
Absolutely.
Definitely. Thanks, Antonia. I think, the engagement with different stakeholders is key there, and just with different groups of people. And we'll hopefully talk about a little bit more about this in the context of model cards, because that's what we're going on to next. In addition to the small practical exercises the students get their hands on, get with, as we've seen in the supermarket model example earlier, they also get the choice of a bigger project, which they conduct over 2 lessons. And they get to choose between classifying data from the world's oceans, identifying fake news, or classifying between organic and non-organic waste. And a key part of the project is the evaluation part and producing a model card. What are model cards? Model cards are a way of just describing and explaining a model, including what it does, what its goal is, its performance, but also really importantly, its limitations. So most machine learning models are designed for very specific tasks with very specific goals in specific contexts and circumstances. So a model card is a way of describing that detail to allow potential users of the model to assess whether it might or might not be suitable for their context. So let's look at the example. Let's say a music venue is looking to use a machine learning model to help with crowd management. They might want to use a facial recognition machine learning model, for example, to know how many people are gathered in certain areas to proactively avoid overcrowding. So the type of information that a facial recognition system might need includes sorry, I want to show you an example of this, which is a real model card of a face detection machine learning model. So the type of information that model card might contain about a model is what type of input does that system need, which in this case, in the case of a facial recognition system, it's either photos or videos. And they might detail its performance in different ways, including accuracy, and importantly, it will detail its limitations. So in this case, we know that this particular facial recognition system does not fare well where face sizes are very small. It doesn't do well where the orientation, where the people are not looking straight into the camera, where there's poor lighting, where faces are occluded, or where there's blurring, all of which tend to happen in music venues. So this potentially might not be the best choice for a model for a music venue. What do you think, Antonia? Can you describe model cards a bit more, maybe a bit better than I have, the information they contain and how they're used in the real world?
Yeah, absolutely. And you explained it really well. I mean, model cards are super important for what we call transparency. And model cards essentially can be thought of a bit like the nutritional information that you get on the back of a packet of crisps, for example. So first, there's the kind of breakdown of ingredients. So for crisps, this would be things like potatoes, oil, salt, etc. But for an algorithm, it might be the kind of data that it's been trained on and the architecture of the model. You then have the kind of nutritional value of the product. So things like the energy this provides, which is calories, and things like the fiber or the protein content. We often think of this of like how good something is across different types of metrics. And we have the same thing in model cards. So where we provide kind of results of what we call model evaluations, which looks at performance across a whole host of tests, which might look at things like how biased a model is across different groups. You then have kind of disclaimers like this is not suitable for vegetarians or made somewhere with nuts. And we also have these kinds of things within model cards. So we might advise people via a model card based on the limitations and the strengths of a model, how they should be used and for what purpose and by whom.
That makes a lot of sense.
So thinking about do you want to talk about the model card for this example, or would you like to kind of run through the model card before?
Yeah, no, I would like. And also, I was thinking, because I described some of those limitations, but I also wondered, do you think it would be worth for the venue in this case to trial out this model? Because I'm also thinking about the limitations, but also what if the lighting is actually really good in this particular venue? Or what if the resolution of their recordings are really, really good? So actually they might overcome those limitations.
Yeah, so I think what's important about model cards is it really empowers the downstream users to make their own decisions. So knowing the limitations of the model would help the venue take a more cautious approach to using the system. So perhaps it might encourage them to kind of test it out in different scenarios before using it to help guide any type of decision making. I mean, personally, I don't think the model would be a good fit. Owing to like all the different kinds of variables that might impact performance. But providing transparency into those variables and kind of giving information on what to look out for would empower them to make their own decision.
Definitely. That makes a lot of test. And yeah, cautious testing. So for their own project, the students will actually get to produce their own model cards. This way they get to think for themselves how these ideas and these limitations materialize in practice for their own projects. So they document their own models, goals, intended use, accuracy and limitations, in helping making the model as transparent as possible for others to understand where the model performs well or perhaps what it does less well. Antonia, we do hear experts talk about FATP, which I think stands for Fairness, Accountability, Transparency, and Privacy principles, especially when discussing the evaluation of machine learning models. What are these principles? How do they relate to model cards?
Yeah, great question. So there are kind of a range of initiatives to establish these kind of ethical principles for adoption of socially beneficial AI, and FATP is definitely one of them. So when we think about fairness, we're thinking about questioning how well algorithmic bias has been corrected within the decision-making model. When we talk about accountability, we're talking about how clear is it as to who's responsible for the model training, the model usage, and the model output. When we think about transparency, we're thinking about whether users are aware that AI is being used to automate the decisions in that situation, and to what extent people can really understand how those decisions were being made. And then when we think about privacy, we think about, does the model architecture actually protect kind of private and personal data that gets inputted into the models? So many of these principles have actually been based on lessons from kind of bioethics, but essentially they all kind of call for the same thing, which is for both the creators and the users of AI systems to take a very critical approach to evaluating their models and to ensure that they serve society in a beneficial way.
That makes sense. And I also wonder about the stage at which these principles get applied, or the use of model cards. In our example, the students in the project, the students are given these projects to work on, and they get to evaluate and create the model card at the very end, which might be actually the first time they might even start thinking about these limitations and these issues of potentially of bias and ethics. And in reality, is it just at the end of the project that they should consider these issues? And what happens in real life, in your experience, from your projects?
So the short answer is definitely no. Earlier, the AI developers consider the downstream impacts of their work, always better. So many of the risks associated with machine learning models can be mitigated early on, much earlier on in the development pipeline. So developers should always take the time to think about how their models might be used in the real world in both kind of positive and negative ways, and then use these findings to kind of help guide decision making. So these can be decisions on the data they use for training, or how they release the model and to whom. But model cards do provide an opportunity to kind of document all this work and share their approach to safety, but should be that rather than the driving force behind that work.
That makes a lot of sense, and that's good to hear. So we've kind of finished the bulk of our presentation for this webinar, but we do have some questions from some further questions, particularly for you, Antonia, because you're the expert here. And one question that we were thinking about, but with students and parents and teachers in mind, was how would you reassure students and teachers and parents about the way in which AI will affect them in terms of bias and accountability, especially since they might not always have ownership of who create over their own data or creating the models in the first place?
So I think one way to kind of reassure parents and teachers is to say that we've come a really long way in understanding how these models work and how to assess them well, and to understand their performance across a variety of fairness and bias metrics. Unfortunately, that has come from kind of historical examples of them not performing well. But being transparent about performance and understanding limitations of models really has become this industry-wide practice, and it's even becoming laid out in legislation from lots of different global governments. So we're really getting there. However, I would really urge anyone interacting with an AI model to approach them with the critical eye. It's important not to put too much trust in their outputs like we do with more simple systems like calculators, and really think about what the machine is telling us.
Fantastic, Antonia. And I hope that creates some reassurance. It reassures me, but I hope it creates reassurance for the teachers listening in today as well. So how do you decide what is ethical? How do you engage with other organizations and social enterprises, charities, to figure out what is a fair and fair representation for a machine learning model?
Yeah, it's a great question. So I can only talk about it from a kind of Google DeepMind perspective and what we do internally. But as I mentioned a bit earlier, we follow a set of AI principles at Google DeepMind, which describe our commitment to developing technology responsibly and work to establish specific areas or applications that we will not pursue, such as things like technology that could be used in weapons or mass surveillance systems, anything that kind of contravenes international human rights. However, we definitely cannot make these very normative decisions alone, and definitely not in a vacuum. And it's integral to include external input across all stages of our process. So whether that be engaging with different experts and impacted groups to better understand how we can maximize the benefits whilst minimizing the risks, or seeking kind of external audit of the safety of our models, we work with a huge number of organizations to support our assessments.
That makes a lot of sense, Antonia. And also because I'm really aware of this kind of, there's no such thing as a bias-free kind of system or an unbiased. There's always going to be bias. What we're really looking to minimize is this unfair bias. So I think, yeah, this issue of kind of who decides what is fair and how those decisions are made is so important and so complicated. And it's nice to get an insight in that. We do have a couple of more questions, but if anyone in the audience wants to ask us any more questions, do let us know in the chat or the question form. Our next question for you, Antonia, is how do bias and ethical considerations change across the life cycle of a project? So, for example, are the thresholds that you might kind of stick to wider at the start, and do they kind of narrow, and do they get refined as you evaluate the model and get closer to a real world application?
Yeah, so I think it's actually really important to set expectations from the outset to ensure that we don't allow these like thresholds to creep as we get under pressure to release something. But having said that, it's equally important to kind of constantly challenge our assumptions and reevaluate what the risks might be posed by certain AI models, depending on how they're being used, how they're being deployed, who they're being used by. And kind of taking learnings from other models in the ecosystem. But as I mentioned a bit earlier, we try to work with teams as early on as possible in their research, and we follow this kind of multi-step process to evaluate the ethical implications. So first, we'll sit down with them and try and assess what the benefits are of the technology, thinking very specifically about who would benefit and in what way. Often we think about benefits just like existing in the world when we release a model, but really a lot of work and a lot of scaffolding has to go in order for those benefits to be actually realized. And we do the same for the kind of harmful consequences, and whether that be kind of intentional misuse, so someone picking up one of our models and doing something intentionally bad with it, or the kind of unintended impacts, so things like what happens when a model performs differently across different people. We then work with the teams to kind of understand how the risks of these things happening could be reduced or even kind of eliminated entirely. And these kinds of mitigations could be technical things we do at a model level, or it could be more general, like engaging with the public on its limitations, or talking to kind of policymakers and thinking about how we can work with governments to build better legislation. Once we have a kind of really good understanding of the risks and the mitigations that we have available, we then kind of ask ourselves whether the benefits really do outweigh the risks. And we will only ever proceed when we believe that really is the case. But kind of all of these assessments are shared with that ethical governance forum that I mentioned, the Responsibility and Safety Council, and they really are the kind of ultimate decision makers on whether or not we proceed with something.
Wow, Antonia, it's so good to hear that there's just such an extensive and thorough approach in terms of creating machine learning models. And I hope there's no one sitting at home with a nightmare of like Terminator 2. We've not made any Terminator jokes yet about this. So I hope there's no one at home listening to Antonia. Just gives so much reassurance that we will have good impact coming out of a lot of the learning models being created. So there's another question. So do you think if AI models are made open source and free completely, so everyone can contribute to their development, there's a higher chance of them learning from more number of humans, and the bias and the system would get squared off much more? So the way Wikipedia, a lot of the information gets to be verified and all of that. What do you think about that sort of approach, instead of like certain tech companies or certain companies being involved in that development privately?
Yeah, it's a really great question. I think it's useful to kind of say up top that there is really kind of this gradient of access. So when we say open source usually says that, the whole code, all the data that it's been trained on, everything is available to kind of external developers. Which is very different to something like ChatGPT, which is kind of hosted behind an API and can learn from the real world feedback that it's given through the kind of chat interface. So they're two different kind of things. And yeah, I think, there is a lot of argument for more open sourcing or like more broader access to allow researchers or members of the public to have more transparency and more input into the development of these models. But it really is a balancing act, and it's not one that anyone has really got clear definitions on, because as great as it is to have people solidifying the facts on a Wikipedia page, not everyone comes into Wikipedia with the same kind of good intent. So we really have to safeguard a bit against that kind of malicious misuse as well, which as models become more capable, can become more of a risk.
That makes a lot of sense, Antonia. Thanks. And yeah, it is interesting to think about kind of a Wikipedia world of machine learning models, because you're right, like the Wikipedia world is also governed or kind of, reviewed and quite a strict process too. So yeah, what would that look like for machine learning models? We have another question that's come in, which is interesting. So how often do live models get re-reviewed? Say if we discover a new impact, so a new context in which it maybe doesn't work as well, or a new limitation, or maybe even a new strength, do they get reviewed is in the question, but I guess this means retrained, basically.
Yeah, so in terms of live models, it again really depends on the way in which it's been deployed. So if something is an AI system powers a product, for example, it's much easier to kind of recall that model if something has been flagged as going wrong, and we can do retraining, reevaluate it, and then redeploy it in that setting. It's very different for the more kind of like open source models where they're available for retraining purposes that other developers can use. But we do have we do really make sure we have a good understanding of the way in which models in general are being used in the real world. And then we use those learnings to kind of feed back into our ethical assessments, so that we're continuously learning from real world feedback, whether or not that's for one specific model or kind of, language models in general, or generative AI, those kinds of things.
Fantastic, Antonia. You just got all the wisdom, all the gems are being dropped right now. And I hope, like I said, I keep saying, I hope everyone's being reassured, because I know I am. So we've got another question from schools, and even being a teacher myself as well. We're always looking for resources, tools, software to improve the quality and reduce time spent. So how do we ensure that the QA, the quality assurance of some of the models that can be used in schools, how do we ensure the quality of that assurance how do we ensure the quality assurance of some of the models that can be used in schools for academic purposes?
Yeah, so there may be different considerations that we would employ for an academic model, but I think, we would never, you would hope that no one would ever release a model that wasn't up to standards across all types of use, not just in academic purposes. So lots of models are evaluated by something we call reinforcement learning from human feedback. Which is where we run a whole sphere of evaluations, and we have people in the loop who are just determining whether or not something is an appropriate output. So that might be the kind of language that's used, whether or not something's factually correct. All these different aspects are like rigorously reviewed by humans and kind of fed back into the system before release.
Brilliant.
Thank you, Antonia. That brings us at the end of the webinar and at the end of our questions. We just want to say a big thank you to you, Antonia. That was really great. Thank you so much for joining us. Thanks for speaking to us. Thank you for your really insightful answers to a lot of questions. It was a real pleasure. Thanks for coming today.
It's an absolute pleasure. Thank you so much for having me.
Yes. Nice.
Thank you. Bye, Antonia. So yeah, like I said, this takes us to the end of the webinar and the end of the whole webinar series about the Experience AI 6 Lessons unit. All webinars have been recorded and are available on YouTube. And we really, really value your feedback. So if you do have any thoughts about the lessons, if you delivered them in your classroom, please do fill in the feedback form and let us know what you liked, what you didn't like. Yes.
Fantastic. And the link is also available. This link is also available at the start of every lesson. So do give us feedback. We want to do better. Thank you again to Antonia. Thank you, Veronica, as well, for being such a great co-host. It's brilliant to have hosted this with you. It's brilliant to hear about all of Antonia's work on ethics and bias and everything. And I think that's all from us. We don't want to go, but we have to go. And I hope that you've enjoyed being part of our web series, our webinars, and you feel a little bit more comfortable and confident. That reassurance. I know a lot of teachers, parents, students, people, educators, want that confidence and that reassurance to bring AI literacy to their classrooms, some to their homes. And we hope to see you soon. I definitely hope to be back. Veronica, do you hope to be back?
Oh, I definitely do, Tessy. And likewise, it was a pleasure hosting this with you.
Definitely. So we hope to see you on any webinar that is run by the Raspberry Pi Foundation. Make sure to tune in. Bye-bye.
Thank you, everyone.